In the 1970s, astronomers witnessed something galaxies were never supposed to do. Outer stars raced just as fast as the inner ones. If physics held true, this should be impossible. So what was everyone missing? Textbooks taught that stars on a galaxy's edge should move slower, dragged by weaker gravity. But here's the twist. The further you looked, the speed stayed stubbornly the same. No one could explain it, yet. While others shrugged off the details, Vera Rubin and Kent Ford pushed for precision. Rubin obsessed over the movement of stars in Andromeda, measuring velocities most deemed routine. But this wasn't just routine. She'd seen a hint of something terribly off. Rubin's early findings didn't spark curiosity, they drew rejection. Experts dismissed her flat curves as mere technical mistakes or bad astronomy. But every time she checked and rechecked, the weird results refused to change. The stakes only grew. Suddenly, the pattern snapped into focus. Rubin's mystery repeated across the universe. Galaxy after galaxy revealed the same stubborn, flat rotation curve. The anomaly wasn't a fluke. The evidence couldn't be ignored any longer. Before Rubin, galaxies were pictured like oversized solar systems, huge clump of mass in the center, outer stars left clinging to faint gravity. That picture made sense until evidence started breaking through the ink of those old diagrams. Some said missing matter would fix everything. Maybe we just can't see it. Maybe cold gas and dim stars outweigh what shines. That theory caught on for a moment until Rubin's evidence grew too big to dismiss. Radio astronomy swept the darkness for unseen gas clouds. Infrared searched for hidden stars, but they turned up almost nothing, nowhere near enough mass. With each empty scan, the mystery surrounding galaxy motion only deepened. Something else had to be there. With every galaxy Rubin charted, the case for invisible mass grew. She published data from dozens of galaxies, and still the scientific world blinked. The more she uncovered, the louder the silence. The contradiction only got harder to ignore. Here's the strangest part. The rotation curve didn't just flatten near the edge. Even as visible stars vanished into darkness, that flat speed persisted. Stars seemed to whip around an invisible core, even out where nothing should be at all. A few scientists started to whisper, maybe something was wrong with gravity itself. Newton's laws worked for our solar system, but galaxies weren't listening. Was there a hidden force at play, or did we need to rethink the universe? Despite mountains of data, Rubin's revelations struggled for publication. Mainstream journals stalled, funding trickled away. Alone among her growing evidence, Rubin pushed on, every unanswered letter strengthening her resolve, each night spent fighting to rewrite the laws of science. The constant skepticism forced Rubin to set new standards, calibrating her spectrograph to extremes, inventing error checks every galaxy researcher now relies on. Her methods became the backbone of how astronomers chart cosmic motion, a legacy hidden in every modern measurement. Elsewhere, astronomers found matching mass mysteries, clusters of galaxies moving as if weighed down by invisible stuff, distant light bent by forces nothing could see. Even far from Rubin's lab, the universe kept echoing her contradiction. By the late 1970s, Rubin's flat curves had surfaced across hundreds of galaxies, forcing global attention. What started as one astronomer's strange data now demanded answers from the world's leading theorists. A scientific reckoning was coming. Galaxies, scientists finally agreed, must be swimming inside enormous halos of invisible material, stuff never seen, only felt through gravity's tug. The solution was obvious and unsettling all at once. Most of a galaxy isn't what you think. It flipped everything about the cosmos. Instead of stars and gas ruling planetary motion, invisible mass became the main player. Orbits bent, planets formed in ways science never predicted. The universe turned out to be mostly unseen and unfamiliar. Rubin's rotation curves formed the blueprint for modern galactic and planetary science, yet her name often whispers in the background, less famous than her discoveries. Her impact changed the field forever, even though full recognition would lag behind. Today, those enormous halos remain science's biggest riddle. We know they shape galaxy curves and planetary movement, but can't yet say what they truly are. Every planet's orbit carries the echo of Rubin's question, stretching out among the stars. Every path a planet traces, even ours, is shaped by invisible forces Rubin uncovered. Most of the cosmos still hides in shadow. You now understand something most science textbooks leave out. Hit subscribe. The next discovery is already waiting.